Okay, so in this video, what you're going to look at is some more functionalities involving data frame packages and other associated packages. Okay, so in an earlier video, we saw one way of reading data from a CSV file and loading it to a data frame. So that was like this CSV, the package name dot file, and to that we pass the CSV file name, and that will load as the CSV file, and we pass that as the argument to the data frame constructor. And on the left hand side, you can have the user defined data frame object name. The second way you can read a CSV file is like this. So instead of csv.file, this is csv.read, and you pass the CSV file name as the first argument. The second argument is the data type or the class according to which you want to load the CSV file. So here you can specify data frame as the class type according to which you want to load the CSV file. So this data frame is a keyword here. And on the left-hand side, you can assign a name you want to assign for this data frame. So I call it as grades df, grades data frame. So I can print this grades data frame. It will look like this. Okay. Let's see. Yeah. So let me load the grades file as well. So this is a grade CSV. I have about 22 rows and about 6 assignments and 4 exams. And the first column is the string, names of the students. Again, this is just some synthetic names I just generated, nothing has to do with any class or anything. And then the 6 assignment scores each calculated out of 100, and the 4 exam scores each calculated out of 100. Okay. Now, Julia has these two functions, enrow and encall, that you can call on for the data frame, like this case, the grades data frame, to retrieve the number of rows and the number of columns in that data frame. So if you call enrow of grades df, it's going to return the 22, and encall is going to return 6 plus 4, 10 as the number of plus 11 for the name. So it's going to be 11 columns and 22 rows. Now, if you want to retrieve just all the student names, you could call it like this. We already saw that you can access a column using the column index or the column number. So again, indexing starts from 1 for the rows and plus columns. So grades df, the data frame, colon means all rows, comma 1, that means the column index. So the column index 1 means the name. So if you look at the file, this is how it is. The name is the first column. So it will retrieve that name as a column vector and basically assign that to this object name, the vector name on the left-hand side, student names. So you can print the student names. So these are the 22 student names. Now, earlier we saw how to generate a matrix out of a data frame. So if you look at this, this is what we did. So the matrix is the class name there, and you pass the data frame object name, and that will generate a matrix, and you can store it as some user-defined matrix name on the left-hand side. So similar idea here, but if you just want to create a matrix based on the assignment and exam scores, you don't want to involve the names here. So you could specify what columns in that data frame you want to be included in the matrix. So again, the column represent all rows, and then you specify the range of the columns from 2 to numcols. So numcols is 11, the number of columns. So columns from 2 to 11 will be, considered for creating this matrix. And we can print this grades matrix like this. So if you print it as it is, just extracted from the data frame, it's going to print like this. So it's going to take the first row, like 165, this is going to be now printed like this. 165, 197, 90, and so on, followed by a semicolon, and then 92, 0, 0, 47, 90, and so on. So it will not be in a typical matrix fashion. So that's why I use this print matrix function that we used to have earlier in the matrix code. And same thing could be used here. So the size method will called on the matrix object will retrieve the number of rows and number of columns as a tuple, which we can make use of to run through the matrix row wise and column wise and print the content of the matrix. So this will print the same matrix like this in a little bit more organized fashion. Okay. And then what we could do is, all right. So now what we want to do is we just have the raw assignment scores for the 6 assignments and the raw exam scores for the 4 exams. So I want to compute add few columns now. One column that has the kind of average of all the assignment scores. Another column that has all the average of all the exam scores. And then I want to compute a weighted average, like a total, that is a weighted average of the average assignment scores and average exam scores. And then based on on this weighted average, I want to compute the overall grade for each student. So this is what I want to do. I want to create these 4 columns. So I kind of initialize these columns to some initial values. So I'm first kind of making them as column vectors, and I'm adding them right away to the grades data frame by using this grades data frame dot operator. And these will be the column names, ASD, average, exam, AVG, and all these things. So since the average scores are going to be numerical values, I can initialize them to be a vector of all zeros. And so the zeros is again a built-in function that you can call and pass the number of elements you want to be in that vector. So in this case, we want it to be for all the rows, for all the students. So you can pass num rows as the argument. Similarly, for the exam average, then even for the total average, which is the weighted average of the assignment average and exam average, we can create as a vector of zeros to be initialized like that. So these are float variables. We can declare like using initialize using zeros. Now for the letter grade column, we cannot make it as a string or we cannot make it as an integer. We have to make it like either a string or a character. And it's going to be just one character. So let's create it as a character column. So I initialize that like this. So again, as a vector of a blank space character for I in 1 to num rows for each row. That's the initial values of all these 4 new columns that we're going to kind of compute based on the previous, the existing assignment and exam columns. So I kind of go through a very traditional for loop here because I want to now compute the average assignment scores based on the 6 assignment scores and the average exam scores based on the 4 exam scores and so on. So for row index in 1 to num rows, so I computed for each row index explicitly like this. ASDF dot ASD average for each row index will be equal to. So what we need to do is retrieve all these 6 assignment scores. So that will be in columns 2 to 7 because column 1 is name, column 2 will be assignment 1, column 3 will be assignment 2, and so on up to column 7, which will be assignment 6. So I retrieve for that particular row index, the 6 assignment scores, sum them up and divide by the number of assignments. I know that number of assignments is 6 because it's from 2 to 7. Okay. Similarly, so that sum divided by 6 will give you the average assignment score, and I assign it to that particular row. So I'm doing it row wise. I'm not using the dot operator to do a broadcast because I need to also add all the 6 assignment scores. So I'll keep the code simple by just going through a traditional for loop and access and updating each row. So initially, each row for these new columns will be like 0 for this 3 numerical columns. So I'm now trying to make them to have the values they're supposed to have. Similarly, the exam average will be the sum of the column values at index 8 from index 8 to 11 will be exam 1, exam 2, exam 3, and exam 4. And for that particular row, sum them up and divide by 4 the number of exams. So that will give you the exam average. Then the total average for a particular row will be the weighted average. So we'll give, let's say, 36% weight to the assignment scores and 64% weight, say, to exam scores. So this value that we just computed, the ASG, AVG for that particular row, and I am multiplying that by 0.36. So since we're doing it only for a particular row, we don't need to add a star in front of, we don't need to add a dot in front of the star. Similarly, no dot is needed in front of the person, anything like that. Then 64%, so 0.64 times the exam AVG value that we just computed. So it's like a weighted average, and that will be the value for the total average. So now based on this total average value, we need to assign the letter grade. That will be the fourth column to be updated. So if the total average of row index value is greater than equal to 85, so it's 85 or above, then the person gets an A grade. So this letter grade column of that row index, this will be, again, it's a character, so I can put within single quote an A. Else if, you see, this is how you write else if in Julia. So this is a place where you get to know how to write else if. So it's like one single word, else if. So if some condition, and then what you do for that, if the condition is true, else if a condition, and what you do if that condition is true. So if the total average is greater than or equal to 70 but less than 85, that means the person gets a letter grade as B. Else if the total average is greater than or equal to 50 but less than 70, the letter grade is C. Else if the total average is greater than or equal to 40 but less than 50, the person gets a D. And then else, it means the total average is less than 40, the person gets an F. So after you write all this if, else if, else if, and then you have an else as well, and then you write an end to show the end of this if and the block. Okay, so this if and the block goes inside the if, else if, and the block goes inside this for loop. So for that for loop, you begin on the top here, you have a corresponding end here. This is the end of that, this statement is the end of that for loop. So you have basically updated the grades data frame, so you can print it out and see how it looks like. So this is the grades data frame. So you have the 6 assignment, 4 exam values, and then the average of the assignment and exam. So this is the average of assignment for the first student, and then average of exam, and then the total average is the weighted average, and then the, since it's greater than 85 or greater than equal to 85, you have letter grade as A. And this is between 40 to 50, and that will be a D. Okay. So now, if you want to retrieve just the column names, there's a method in Julia called property names, and you can pass the data frame object name, and that will retrieve the column names. So now what I want to do is, instead of viewing all the individual assignment scores and the weighted average, total, the assignment average, exam average, total average, and all these things, I just want for each student the corresponding grade. So I can, it's like a select query, SQL query. So select, that's the keyword, the function name. And then you can pass the data frame object name, in this case grades df, and then the columns you want to look at. So the column names of one, so that's why I'm retrieving the column names. And you know the first column is the name of each student, and the last column by now will have the letter grade. So if I, and this is a vector, the column names, the property names function returns the column names as a vector. So if I call the length method on that vector of column names, that's going to retrieve return the number of columns in that data frame. So we're calling it on the grades data frame. So the number of columns in the data frame will also correspond to the index of the last column in the data frame. So if I call it as column names, and then within square bracket, I pass the length of column names, that will be like the index for the last column. So that will be the letter grade column. So you can see how it gets printed. So I'm directly passing that to the println function. So this is how it gets printed. Again, for each row from 1 to 22, the student names and the letter grade. So remember, the letter grade column is a character column, so it's just only one character. Okay, so now what I want to do is I want to find out all the different letter grades the students have got in the class. Uh, so I want just basically I want to construct a distribution of the letter grades and do some analysis. So if I call on this grades df data frame object dot letter grade, it's going to return a vector that comprises all these letter grades A, D, A, F, C, C, and so on. It's a character vector of 22 elements. Now, I want only say, this is another function which we have not seen so far. Out of these 22 entries here, you'd see there are a lot of duplicates, right? So we would just want say unique values of the elements in a vector. Then you can call the unique function and pass that vector. The unique function will return only, will basically return another vector that has only unique values from the vector to which you're passing. So in this case, it will be just A, B, C, D, F. But the unique values will not be sorted automatically. They'll be retrieved in the order they appear here. So A is the first character which has not been seen so far in this vector, then D, then F, then C, then B. So the unique function called on this vector of these 22 values will return A, D, F, C, B as the vector of unique character values. So you want to sort it so that you can easily kind of see, okay, what are the letter grades in the sorted order. So you call the sort function on that vector of unique values, and that will sort it as A, B, C, D, F. Okay. And again, I'm not passing rev equals 2 to sort it in reverse order, so it will sort it in increasing, in this case, lexicographic increasing order, so it will be A, B, C, D, F. Okay. So that's what the letter grades vector will have. It will have the sorted order of the letter grades. So now what I want to do is I want to loop through this letter grades vector whose entries are say A, B, C, D, F. And now I want to create separate data frames. So I have now so far one data frame that has all the 22 records with all the different letter grades, one for some letter grade for each row. So now I want to create data frames comprising of records or rows only for a particular letter grade. Okay, so I can do it like this. Again, the subset function that we saw earlier. So you want to get a subset of the data frame. So in this case, you want to get a subset of the grades DF data frame under the condition. So this is the condition that we want to use to extract the subset. So again, column letter grade, we are trying to access the letter grade column, and the dot two equals. So basically doing a comparison, you're comparing the values in the letter grade column across all the rows to this entry here. Letter grades is a vector of unique grades of grade index, so a particular grade. So the first grade index at index 1 will be an A. So that means whatever column entries have an A, because you're doing a dot 2 equals, so all the rows will be considered for the comparison. So whatever column rows whose column entries for letter grade is an A grade, those will be just extracted and passed on to this grade wise data frame. Okay, so you can say data frame for grade, letter grades of grade index will be say A, and then you can print that grade wise data frame. So it will be something like this. The data frame for grade A will comprise of just all the students and the assignment, 6 assignment scores, 4 exam scores, the assignment average, exam average, total average, and then the letter grade A as well. So it's just retrieving only a subset, but including all the columns. You're not filtering any column while extracting the subset. Okay. Now, you can do that for each letter grade by going through this loop. So that means you're extracting 5 different data frames, one for each letter grade. So this is for a data frame for letter grade B, and then for C, for D, for F. So this shows that if you have a huge data set, you can extract sub data frames of that data set and analyze for under some particular condition, and then analyze just that data set and infer some information that you want to extract out of that data set. Now, there's another function that we can make use of. It's called the @by method or function. So both subset and by come under the or are part of the data frames meta package. So you need to make sure to include that. And all the sum, everything, anything that you do with statistics is needed in a stat-based package. So you need to include that as well. And matrix is part of the linear algebra, so you'll include the linear algebra package as well. Okay. All right. So now what I want to create is something like this. So I want to create now for each letter grade, basically a data frame where each row is a letter grade like A, B, C, D, F, or it could be just you don't need to sort it as well. So just for the unique letter grades. I want a list of students. So one column that has just a list of students' names who got that particular letter grade, like this A grade as so the letter grade is the first column. And for grade A, these are the names of students who got A grade. And that list could be a way of variable size. So some grades would have been got only by two students. Like for example, the F grade is for, only for two students, and then the C grade is for three students, but some grade would be for four students. So it depends on the grade. So that this is a scenario where a particular column has a vector of strings, and the length of that vector could be a variable. Okay, so the length of that vector, so as you see here, this is all these are a string vector of strings, and this vector is of length 2, this is of length 3, and so on. Of course, the output just displays three names at most, but that's why we have a count that gets the length, the number of students who got that grade. So let's go through this in detail. So the at by is the keyword, and then the underlying data frame on which you're executing this by method. So the at by is basically a combination of extracting the groups. Okay, the groups are by according to the letter grade, and then combining some information, mostly the statistical information, as you will see here. So you're grouping by letter grade. So immediately, so that's the syntax. So immediately after the data frame object name, you will put the column name. That's the syntax for using the column name in Julia, colon, letter grade, the name of the column, based on which you want to group the records, and then comma. So what column names you want to be included in this data frame? So we're basically creating a new data frame now, grouped by letter grades. So each entry in that data frame will, each row in the data frame will be for a particular letter grade. And so the letter grade itself will appear as the first column in this new data frame. As you'll see here, the letter grade itself is the first column. And then the second column and all subsequent columns is up to us what columns you want to create in this data frame. So what I want to create is like a column names that will have like a vector of string values comprising of the names of the students who got a particular letter grade. So remember this NAME capital N is the column name in this original CSV file, and we kind of retain the same name throughout in this grades df. We did not change it. So this is basically the column name of the student names, and you want to put together all the names who got that A grade across all the rows in a vector. So if you put inside square brackets like this, it's going to include all the student names who got the letter grade, uh, a particular letter grade inside this column vector. Yeah, this inside this vector of strings, basically. And then that will be the value for this names. Okay. And then this count value, again, you are trying to set it for each row. Each row will comprise of a particular letter grade. So the count is again all the left-hand side names or something that we are creating. So it could be anything you want. And the only thing is you should put a colon in front of them as a syntax. And the right-hand side, so the right-hand side names come from the grades DF. Okay, so that's a way to remember is left-hand side names are going to be the column names of the new data frame that we are creating now, and whose name is declared on the left side of this at by function. And the right-hand side here in each assignment or column names in the underlying data frame, the grades data frame. So this name is the name column for student names in the underlying grades data frame. So that's why I'm differentiating that by making the column name in this data frame to be names, because it could have more than one student name for a particular letter grade, a vector of names. Now, so I want a count of this, how many students who got that particular letter grade. So again, you are grouping by letter grade. So automatically it will consider only those records. So this is the a column that you are mentioning to group by immediately after the data frame name. So the grouping will be according to that column, unique column values. So it will consider only all those records that have a particular letter grade, and the number of such rows will be the length, and that will be assigned the count value. So in this case, if you see a 6 here, that means 6 students got an A grade in this out of 22 students. Then 3 students got a D grade, 2 got an F, and so on. Then you want the average assignment score of just those students who got a particular letter grade. So what you do is you already got ASG average, that's the average of the assignment score, 6 assignment scores for each student. And you got like for example, you're looking at all those 6 students who got A grade. You take their ASG average scores, okay, sum them up and divide by length of the name. So length of the name again is the count, the number of students who got the particular letter grade. So sum divided by length will give you the average. So this is the new column name for this grades by DF data frame, the average AST score. And that will store you the, so basically you're putting together one number here, in this case 89.5, that's the average assignment scores of the students who got an A grade. And how you're computing that average assignment scores, you're taking the average of the average assignment scores of those 6 students, basically adding the average assignment scores for each of those 6 students and dividing by 6. And you can do the same thing for the exam. Average exam score, that will be the column name in the grades by DF data frame. And this exam AVG is the column name for the grades DF, divided the sum of those values divided by the length of that name, that will be the count. Then the average total score will be basically related to the weighted average, the total average sum of that divided by the count. So you could do all these things and print the grades by DF. So that's what I'm printing here. So now, again, the grades are not sorted, so you're not really able to visually look at, okay, or the average assignment scores or any of the assignment score, average scores decreasing with grades as we go from A to F. So you want to look like that. So what you could do is you could sort the grades by DF data frame, and you want to enforce the sorting. So you put exclamation mark, grades by DF is the data frame, and then you want to sort by the letter grade column. So you could pass the letter grade itself like this. Now you could pass more than one column also for sorting. So it will sort first by the column you list first, comma, if you list the second column, it will list accordingly. So it will consider the columns in the order in your listing. Okay, and when we look at the next video, I'll show you that you can sort really based on more than one column in the order of listing like that. But here we just want to sort by letter grade, so just put that column name inside the square bracket. And actually, if you're that's just sorting using one column name, you may not even need a square bracket. Let's try and see. Yeah. So A, B, C, D, F. So yes, if you're just passing one column name for sorting, you don't even need to list the column name inside the square bracket. But let's keep it, because if you want to do it for multiple, then you would need to pass using inside square bracket. Let's follow uniform convention. So now you see here, as we move the grades from A, B, C, D, F, the average assignment scores, that's easy to look at. The average exam scores are here, and the total average are here. Is here. Okay. All right. So the average assignment scores 89.5, then reduces 74.8 for a B grade, then 65 point something for a C, 42 for a D, and 10 for an F. So it makes sense. And similarly, the average exam scores also reduce, so the weighted average also reduces as you move down the grades from A to F. Now, if you want, you can store all of this to a new file using the csv.write function, because this is like a statistical analysis of the grades that we have got. The grades, the student names, and the count, number of students who got each grade, and the average scores in each category, assignment, exams, for just that particular grade, and so on. So in the earlier video, we saw how to write to a CSV file. So we can make use of that, like here. So you can make use of this syntax to write a data frame to a CSV file. So you can write this statistical analysis, the grades by DF. If you sort it and enforce it, then the sorted order will be copied to the CSV file. So let's stop with this.